today we're going to kick things off with Dan, who's head of data at Dataform. He's going to be talking a bit about the benefits of building a centralized data model. He'll give an example of how to build a data model for product analytics, and he'll talk a bit about data modeling principles and best practices, kind of traditional data modeling kind of methods, and why he thinks we should be moving away from them. Then we're going to move to Saadat, who is the founder at Modern Data Sciences. Modern are a data consultancy who basically aim to help their clients become more data-driven and help them kind of build data-driven cultures. And a big part of what they do is helping their clients build a centralized data model. So he's got a lot of kind of great real-life use cases to talk about. And they'll be speaking a bit about why they chose to move away from the kind of traditional data modeling methods in favor of a more agile approach, and some examples there too. So just a little bit of background before we begin on why we started the Modern Analytics Academy. Over the past 2 years, we've kind of worked with various different data teams, and we started spotting patterns in the way that the best teams worked. These were the teams that were able to deal with the complexity of the kind of vast amount of data that modern organizations have to deal with, whilst also kind of supporting their organization's demand for kind of data-driven decision-making. And the patterns that we kind of identified, we call modern analytics. And modern analytics uses the technologies and workflows of software engineering to deliver the analytical outcomes demanded by the modern organization. And we think that modern analytics is scalable, agile, and collaborative. And so we basically took all of this knowledge that was in our heads and put it into a kind of more digestible format. And we wrapped it up into the Modern Analytics Academy. And so, yeah, what the Modern Analytics Academy is, we started off with 4 kind of core chapters, an intro, a chapter on why we think you should be moving to an ELT approach rather than more kind of traditional ETL approach, a chapter on data modeling and building a single source of truth in your warehouse, and then the last chapter on data quality testing with assertions. Like I said, we started with 4 kind of core chapters, and we aim to produce more content as we go on. You can subscribe to the Modern Analytics Academy and get sent new content straight to your inbox. And as part of the launch of that academy, we set up a series of webinars with analytics leaders in the data space to talk about these concepts in a bit more detail. So that's what today is. And then, so next week we have the last in the series with Sean from Cisco Meraki, and he'll be talking about how their team built out a data quality testing framework, and yeah, how you can kind of ensure that your data is trustworthy and reliable by using these automated tests. Cool, so without further ado, I'm going to hand over to Dan now, who can start his talk.
Great, thanks, Josie. Yeah, so I've been working at Dataform with Josie and others for about 18 months, and something I've spent a lot of time on in the last few weeks is putting together the Modern Analytics Academy, of which the data modeling chapter was one. And so, yeah, kind of talk through some of the concepts behind that today. I'll probably be moving reasonably quickly, but I think this is a reasonably kind of advanced crowd. So yeah, apologies if I'm moving a bit quick. We can kind of come back with questions at the end. So first question then, what's a centralized data model and why do I need one? I think for most of you, this is probably, you probably have heard about the idea of data modeling before, but I think the kind of the core issue here is that answering simple questions with data is never simple. It's always difficult. So the question itself might seem easy, but the actual practicalities of going about answering the question are always harder. So in this case here, like let's imagine a simple question, which of our app providers brought us the most new customers last week? Sounds kind of easy. In practice, there's a whole load of steps you need to go through to do a good job of answering that question. You need to understand like what ad providers does our organization even use. Then once you've understood that, where are the data sets that actually contain the information I need for answering this question? those data sets from Twitter, Facebook, Google, they're all going to be in a slightly different format. So you've got to work out how to actually bring those together into a consistent format. Join these tables, run some checks, make sure that the way I've joined them together hasn't caused some issues. Probably need to join that with some other information on like our customers. Then think about some attribution logic. What if one of our customers has actually seen 2 ads, one from a different provider? Like who gets to kind of count that as a win? Do they share it? Is it the first touch, last touch? And then eventually, once we've done all that process, we can go back to the marketing team and we can start to actually answer that question and help them understand what's going on with their marketing campaigns. So a really long process, can take a lot of time. Each of these steps has a potential for making a mistake. And honestly, if 2 different people started this process, by the end, you've got a decent chance that you'd have slightly different results from both of them. Not because they weren't good data analysts, just because this is just really complicated stuff. So what we need to do instead is, rather than having to go through that whole process every single time you get asked this question, instead we need to start creating a kind of single source of truth for answering questions about marketing. In this case, a marketing attribution table, which is what I'm kind of calling the data model. And once we have that single table, that serves as our jumping off point for answering that question. So of course, we need to go through that process that I've just showed you before once, but rather than kind of kicking that off every single time the question comes in, instead we set up this marketing attribution table, make sure it gets updated on a regular basis, and then this is the place we come to answer that question. So now answering that question is just a few lines of SQL hitting that one table, very little chance for me to go wrong here. And of course, this is now taking me just a couple of seconds, and in actual fact, you're probably using a BI tool to answer this question. So now we kind of save the time, we can avoid making common mistakes, and more importantly, everyone across the organization is aligning on a common set of definitions that are baked into that, creating that data model in the first place. So that's data modeling. Hopefully that kind of makes it clear why you might need it. And we're fortunate enough today to be in a place where creating a data model is actually really easy. There are lots of tools that help with that process. Data collection and integration is made a lot easier than in the past with tools like Segment and Snowplow for collecting events data, Fivetran for kind of integrating data from other tools into a data warehouse. The cloud data warehouses, places like BigQuery and Snowflake, provide a SQL-based environment for storing, transforming, and sharing data. And all of these BI tools plug in nicely to that cloud data warehouse. And then to go alongside that, there's a new wave of platforms, of which Dataform is one, which are designed exactly for this data modeling in a cloud data warehouse environment to actually manage that data modeling layer. So just to kind of make that all a little bit more real and visceral, I wanted to run through a common data modeling example that we do ourselves at Dataform for our internal analytics. So a lot of the analytics that we do internally is around is what I'd kind of describe as product analytics. So understanding how our customers, how our users use our product. So the kind of questions that we might want to answer would be something like, how long does an average session last in our product, and how has that changed over time? What percentage of sessions contain a transaction or some usage of some feature? And what's the last thing people do before ending a session? Like, why do people ever leave the Dataform app? These are the kind of questions that we answer, that we ask quite often. Answering them would follow a pretty similar complex process to that chain that we looked at before. So instead, we've built this kind of simplified sessions table, which is our data model for doing product analytics. So the sessions table takes all of the different events that happen in our app, brings them all together into one table with one row per session. Each row in this table represents an interaction with the Dataform product, an uninterrupted period of activity. So someone logs in at 10 a.m. in the morning when they've started using Dataform, they use it for 2.5 hours and they go away. That's going to be one row in the sessions table. And then if you're lucky, you're using a cloud data warehouse like BigQuery or Snowflake that allows you to store arrays or lists within an individual table. And at the end here, you can see in that events column, we actually have a list of all the different events that happen within that session. So we really understand how that user interacted with our app. So once we've formed this one sessions table and we have that ready, answering the kind of questions that we looked at before, it becomes easy. So now, how has average session length changed over time? Previously, that would be a pretty complex SQL query. Now that we have this sessions table created, It's just a few lines of SQL to answer the question. So yeah, at the beginning, a data model, yeah, sounds kind of simple. We might bring together some source data, some add information for this like marketing attribution table. We have some event data and create like a sessions table. And so we've got several sources of data and we're combining them. We create some like simple aggregates that power all of our analytics. Most organizations are dealing with a much more complex variety of data sources. And so it's not unusual to be working with hundreds of tables, and your data modeling layer probably looks a little bit more like that. So then the question becomes, like, how do I actually kind of manage that level of complexity? Are there some methodologies out there that I can lean upon? And it turns out there are. So data modeling isn't a new idea. Over the years, people have developed a few different approaches to managing a data model, and I just want to touch on a couple of them now. So the first one, probably the most common that you might have heard about. I managed to work at Google for 10 years, 7 years as a data analyst, and never hear about any of this, but it's a reasonably well understood concept within the kind of data analytics workspace, the idea of the star schema. So it's been around since about 1996, developed by, I think, a guy called Ralph Kimball. And the idea here is to break your data model into basically two different types of data set, a fact table or a dimension table, otherwise known as facts and DIMs. So facts represent a business process, i.e. some measurable quantitative data about a business. And the kind of canonical example that people talk about is a sales data set, so like fact sales. Dimension tables describe attributes related to fact data. So things like products or stores or potentially even dates. So that's a bit abstract. What does that really mean? A data model built around the star schema would have this central fact table that stores kind of one row for every day, store, product combination with some metrics like number of units sold. And then surrounding this fact table, we have a bunch of dimensions that join in on the central fact table on these ID columns, and you can then kind of pull in the relevant information. So if you wanted to understand how sales have changed over time by product, you'd be writing a query against this fact sales data and joining in on the product dimension to pull in, let's say, a kind of product name, and then on the date dimension to filter on dates. So that's kind of the vague idea behind the star schema, and the name comes from the kind of what this looks like pictorially as you represent it like this. So pros and cons of the star schema. From on the kind of advantages side, it's the queries that you have to write when working with a star schema are relatively simple. You're usually just doing a few joins, and the overall structure is pretty simple to understand. In practice, when I worked with it myself, I found that it's not ideal that the individual tables themselves aren't particularly useful. They're kind of littered with these IDs that don't necessarily mean anything to you. So you're always like one join at least away from anything useful. I've also found that the delineation between fact and DIMs is not always clear. I think in all the textbook examples, it always makes a lot of sense. When you really start to think about building a star schema for your own business, not everything kind of fits into this kind of clean category. And complex analytics don't really fit into the paradigm quite as well either. So the idea of like retention doesn't really fit into this kind of model of like a business process. So that's one of the more common data modeling methodologies you may have heard about. There's another one I just wanted to touch on, which is a little bit newer. It's something I've heard be talked about a little bit more recently. I'm not quite sure where it came from, and I'm not sure kind of if anyone in particular came up with it. But the idea behind activity streams is that you create this one central time series data set through which all of your information flows. So this might look something like this. You have this one activity stream data set, and each row in the activity stream is essentially some activity, some action that a customer at your business took. And so in this example here, you can see we've got a few different activities. We've got this one user who's clicked sign up, created an account, opened a page, viewed some item image, and then logged out. So each of those actions that this customer took is represented by a row in this activity stream. We obviously need the user ID to understand who did it, and then we have this kind of room for some like extra properties. So for example, if they sign up, we need to know what email address did they sign up with. the idea then is once you have this kind of central activity stream table with a consistent set of fields, everything can then flow into that table. So when you have a new question, new type of analytics, you think, how can I express this question in terms of events or activities that I can feed into the activity stream, and then all of my downstream analytics is built on top of that. So it's kind of a nice idea, the idea that you've got this one table and everything stems from that. So again, like looking at pros and cons of this method, pretty different to the star schema. Some of the pros, adding to the data model is kind of simple. You just have to think, how do I add a new activity into the front end of the activity stream? Another kind of advantage here, it seems to be pretty well suited to a streaming approach. Like time is a very important concept to the way that the activity stream is put together. Alternative, on the other hand, answering the specific questions of using this activity stream table can require some pretty complex queries. And this activity stream, especially if you're a large organization, can be an absolutely huge table. So you have to be pretty thoughtful about how can I write a query here that's not going to be too slow or too expensive. So these are just a couple of methodologies that are out there to help you think about data modeling. There are definitely many more. In my experience, whilst they're all interesting and they all bring something new to the picture, in practice, I don't find that any specific one works for like all the use cases I've had in my experience. So instead, what we would kind of recommend at Dataform is to keep in mind a set of guiding principles that can help you as you develop a data model. And so I'll kind of run through those now. So here's a few of the principles that I'll run through. Here's 5, and I'll kind of talk about each of them individually. So the first one that we talk about a lot at Dataform is that you should define your transformations with SQL. So there are many languages that you can use to work with data, like Spark or Python, Java, loads of others. Probably work with data with almost any language you wanted to. We strongly prefer and recommend using SQL. For many reasons. Here's a few of them I listed down. One of them is it's designed specifically for transforming data, so it suits the purpose really well. It's widely understood and quick to learn. It's relatively easy to maintain and debug. If something doesn't look right in your query, you can kind of run it, inspect the data, see what's wrong, go back and make some changes. And probably one of the more important points here is that the modern data warehouse, SQL engines in modern warehouses scale extremely well. So in general, you don't need to worry too much about optimizing your code. You can just write the SQL and let the data warehouse do all of the optimization for you, which is a huge benefit for the data team. Another principle that we try and stick to is when you're writing your transformations with SQL, try and write them by defining them as select statements. So avoid using things like inserts and updates, upserts and deletes to create your data model. The advantages of a select statement is, well, one of them, you can look at a select statement and you pretty quickly know what you expect the output to look like, what the shape of the output data is going to look like. So again, this makes it much more easy to debug and maintain the code. If you've made an update to the select statement, you want to see what the output looks like, you can just run it and have a look at a sample of the output data. And also really importantly, if you need to recreate the data model, maybe you've accidentally deleted it or something's gone wrong in one of your pipeline runs, it's just a case of rerunning the select statement once and then the output's recreated. And in the kind of in the paradigm of batch data processing, which is what we're doing in data modeling, being able to just rerun something to recreate everything from scratch is really important. Another one, well, this is generally considered a software development best practice. Don't repeat yourself, but really data modeling involves writing a lot of code, and so you can definitely learn a lot from software engineers. The principle of don't repeat yourself basically says avoid writing the same piece of SQL logic in many different places. This is because if you ever need to change it in the future, and typically the data models do change a lot, if you've written the same piece of code in many different places, you're going to have to go and find it in all of these different places and update it to make sure that your data model is correct. So in this example here, we've got this field that we actually have, we use a lot in our data modeling Dataform, we have this field called internal user, and this basically says, is this one of the Dataform employees that's using our app, or is it someone else? So you can see we're just comparing the email address to this string dataform.co. So we use this field internal user in lots of places, but we definitely don't want to be writing this snippet of code out lots of different times. For one reason, if we ever decided we wanted to update our email addresses, maybe to dataform.io, for example, then we'd have to go and find all of these instances of this statement and make an update. So instead, what we do is we define like an intermediate table where we pull out the email address, annotate it with this field internal user, and now in all of our downstream queries, rather than having to write out this if statement over and over again, we can pull in that field from staging users, and everything else benefits. So now if we ever do update our email address, we can just go and update this one piece of code in one file and everything else will benefit. The fourth one, I think, Saadat's probably going to cover this a little bit in his talk as well, but the idea here is there could be a temptation with data modeling to think about all of the potential questions that your business might ever ask you and see if you can design the most complete, perfect representation of your organization so that every question that could ever be asked is covered. In my experience, that's not really going to work. Like, businesses are just too complex, things change too much. And if you spend your time kind of trying to predict the future, you're essentially going to be wasting time. And so instead, I would recommend focusing on the questions that are being asked of you now. Build a data model that works for you now. It's almost certainly going to change. You're almost certainly going to have to update in the future. But that's just kind of that's the fun of the game. And just trying to kind of stay agile and respond to the needs of the business is going to serve you well. And finally, this one sounds a bit strange, but humans are more precious than machines. So in the data team, I'd be surprised if it wasn't the case for most of you, if human capital is probably the most precious resource you have, and probably the thing you're most constrained by. So my recommendation would be to be really skeptical of time spent optimizing query cost or performance. There may be the odd time when that is actually worth your effort, but in general, it's not going to be worth your time. You'll be better off focusing your time on how can you use your data to help your business progress and improve and deliver insights to your business partners. So an example here would be like denormalizing data. Some people might say, well, it's not very efficient. You're like using more storage space in the data warehouse. That is true, but a denormalized data model is far easier for your analysts to use, and it's going to allow them to move more quickly, waste less time, and serve the business better. So yeah, generally speaking here, I'd say try and measure the effectiveness of your data model by how convenient and easy to use it is for analysts, not necessarily how like cheap it is to run or how kind of how performant it is from a time perspective. So yeah, they're the kind of 5 principles. One thing I would just caveat all of this with is there are times when you might want to break all of these rules. They're kind of litmus checks to keep in mind, but there's almost certainly going to be a time when you might want to stray away from them. Cool, so that was everything I wanted to talk about. Just quickly summarizing, a centralized data model allows your team to scale their impact, reduce time to insight, align on consistent definitions, and make sure that everyone's benefiting from the work of others. Try and focus on designing a data model that delivers value to your business, and think about some fundamental principles that you think will help you and your team scale that data model. And if this has piqued your interest and you'd like to take your team's data modeling to the next level, I would recommend you check out Dataform. We've designed the product exactly with data modeling in mind, and we've tried to bake in a lot of these best principles into the design of the product. So yeah, check it out. Cool, that's me. We're going to do questions at the end, so I'll just hand straight over to Saadat.
Thanks, Dan. Josie, do you want me to just start sharing?
Yeah, go for it.
All right. Go to presenter mode. Oh, thanks, Dan. That was a really insightful talk. I have taken an interesting angle. It's threading off of some of the things that Dan spoke about in the first session today. But I'm excited to talk to you about some of the things that we've been learning about building data models. So yeah, the agenda for the next 20 minutes, quickly just introduce myself and some of the problems that I'm working on with my team members. I'll introduce this problem that I call the traveling Salesforce problem, and then talk about why that has resulted in us thinking of centralized data models and specific to B2B SaaS. And then leave some time for questions at the end. So really quickly, just this is an introduction to me. So I'm currently leading infrastructure and strategy at this company called Modern that I helped found. I have a pretty standard career trajectory for almost everybody in this room that's really working as a data engineer. So systems engineer, and then found my way in software development, and then realized that I really loved working with data. And I begged one of the product managers of the company I worked at to let me become a product analyst, and eventually found my way into the data engineering team. So in a trajectory that probably will be familiar for a lot of you on the webinar today. But I've been very lucky that I got experience today because over the last 5 or 6 years, I've had the opportunity to consult with some world-class B2B SaaS companies like Envision, CV Insights, and Wealthsimple, and learned a ton over the years. And what you'll see today over the next few minutes is a distillation of some of the concepts I've learned. And also, if anyone's interested, based out of Halifax, Nova Scotia, which is on the eastern coast of Canada, and it's a beautiful place to live. It's got a very, very nascent but interesting tech scene. So you should come check it out when the world goes back to normal. Okay, so I'll start at first principles and walk you through an article that heavily influenced our way of thinking and almost was a foundation for why we want to start a company. So there's an article written by Monica Rogati, who was at that time in 2017 a VP of data science at Jawbone, and she had come up with this concept of a hierarchy of needs for data science. And the synthesis of her article is simply that companies have to progress up this value chain. You have to get the foundational pieces in place before you can get to the fun stuff, which is all about learning, optimization, and the magical AI buzzwords. But you can't get to the top of the pyramid without actually getting your foundations in place. And we've taken Monica's thesis and we sort of built our own sort of pyramid, which essentially does the same thing, but generalizes it for the world of business intelligence and for data engineering in particular. And so what we found over the last few years working with clients is that most people do a phenomenal job of getting to this collect, store, and then that exploration phase. And it's been propelled by advances in data warehousing technologies and in new tooling like Dataform and dbt and Great Expectations and all the new tools that we're getting to play with on a daily basis. But what we find is that a lot of companies get to that aggregate stage, and then that's when they tend to get, there's a little bit of inertia at that point. And we think that the real value to be gained from data is once you can progress past the aggregate up until the learn, predict, and the act phases of that journey. And so the whole purpose of our existence is to try and help our clients accelerate the time to develop and from the collect to aggregate. And then once you've got that in place, once you've got basic reporting out of the way, let's try to focus on how can we use your data as an actual asset. So what that means for us on a daily basis is that we get exposed to a lot of tooling. And you saw from the last webinar, and even it's hard to escape the conversations happening about the ELT paradigm. But we think that there's actually two additional parts of the stack or two additional layers that aren't really spoken about a whole lot, even though they're a fundamental part of how we work today. And now that's the visualization stack, where we have to spend time. We have to find ways to allow people to visualize that data. And then there's also a new model for the ACT stack, where we're trying to get data models out into platforms that matter. So that would be getting your customer data back out into Salesforce or your product data back out into HubSpot. So these are two new parts of the stack that we're spending a lot of time working in. And what you'll find today, what I'm trying, the synthesis of the talk is, if we can get the data model right, it allows us to build a visualization stack and to build the axe stack much faster than if we didn't have a centralized model. So we're not Salesforce admins on the webinar today, but I think this is a problem that a lot of you who work in B2B or have ever experienced Salesforce will commiserate with. And what I've got up on the screen is an example of some example applications that our clients tend to use. So if they've got customer success in place, it's probably because they've scaled a certain point where there's a customer success team. Something like Zendesk or Vitally is already in play. There's probably some form of application data. It has its core user data. It's got product analytics. It's stored in MySQL or Postgres. Our clients typically always also have a CRM like Salesforce or HubSpot. On the finance side, there's going to be something like NetSuite, QuickBooks, SAP, or Stripe might be a better example. And then there's going to be something else like a heap or a segment. And then on the marketing side, Intercom, Marketo, Eloqua. So this is probably, as you think about your own company and the type of work you're doing, you're probably seeing something like this where there's one type of software, one type of SaaS product that's managing and maintaining data for that particular type of product. And what ends up happening, we see this a lot when we started working with clients early on, which is there's a desire to try and make Salesforce a center of gravity for a lot of this information. And it's done for various reasons. And we think that from a strategic perspective, it kind of makes sense. Like, if I'm an engineer and I've been asked to try and serve data to a salesperson because we believe that's what's going to make them most productive, it actually is the right thing to do. So from when we think about it, so the people closest to the customer should have access to the data that they need to be successful. So that's, we understand why our clients are choosing to do that. And having some of the data in Salesforce is pretty beneficial because you can start to answer some questions like this. So, does this customer have an open customer support ticket? When was the last time the customer logged into a SaaS product? And one of the most interesting questions we get is this customer about to hit their product usage limit, especially when your pricing model relies heavily on some form of usage limit. And if you zoom out a little bit further, you can start to think about like, well, what are the other questions you're trying to answer inside of Salesforce? So things like, well, what's my sales forecast for the current quarter? How many ops were created this past month? And how many leads did a particular campaign generate? So from a data strategy perspective, trying to get that information to Salesforce has merit. So we agree with that. But then there are some problems and it's primarily because Salesforce is not designed to be an analytics application. It isn't, if you think about the underlying data model, it's effectively a transactional database. It's got accounts, contacts, users, and a bunch of other objects that have a very normalized structure. And every instance of Salesforce where we see a number of custom fields being created, it's always in the intent of trying to do better analytics. It's not just to try and give the salesperson visibility into performance of an account. And so what this results in is significant amount of technical debt. And now this is one screenshot that I was able to find of, and it's a horror story that I've had to see where we've inherited an account with a Salesforce account with more than 400 custom fields. So if any of you have ever worked in this space, this is not a very uncommon thing to experience. Now, we're not exactly Salesforce administrators, we're data engineers, but this is a problem that we see a lot. And it's gotten to a point where we're starting to ask the question, could we design our analytics systems to try and help alleviate some of this pain? And I know all of you are thinking, well, I signed up for a talk on data modeling. When's that coming? And the answer is just hang on. So we've taken a lot of inspiration for the way we design our data models and the way we want to think about things from this incredible book by Daniel Kahneman, which I'm sure some of you have read it or maybe heard about it. And in this book, Kahneman basically says that there's the way humans think and the way we perceive signals and information, there's effectively two different systems. One that he calls type 1 is effectively, it's designed to allow us to to react in real time. So it's automatic, it's impulsive. It's what allows us to have knee-jerk reactions to other stimulus. And in addition to a type 1 system, we also have this system that allows us to do more conscious, deliberate manipulation or analysis of data. And that's what he refers to as type 2. And so what over the years we've realized is that data systems sort of follow a very similar pattern, right? If you think about it, like our jobs as engineers is to provide information to people who are going to make decisions. Can we try and design our systems so that we can try and almost appeal to the way the human mind thinks, which is there's always going to be type 1, there's always going to be a type 2 system. And so we think that we have to split up the idea of an operational system and an analytics system. And so if you think of the questions that I posited in a few slides ago, so things like, does this customer have an open customer support ticket? That to me is a classic example of a type 1 question. It's trying to deliver a fast response to a question that doesn't require a lot of complex analytics. On the bottom half, I've got questions that require more analysis, require a lot more thinking, a lot more analysis, or a lot more investigation before we can actually understand what's happened over time. And therefore, one of the things we're trying to realize now is how can we design our analytic system to try and match the way our brains are trying to adapt to stimulus. So I threw up this a few slides ago. So we think that trying to build a center of gravity for data inside of Salesforce is probably not the way to go. And instead, what we want to do is almost start to collect all of our companion apps into what's not going to be a surprise to anyone here, but into a centralized warehouse. And then treat Salesforce as one of the outputs of that system. And so what that means is we not only need to have something like Salesforce that provides operational insight, but we need to have some form of a business intelligence tool like a Looker or a Motor or a Sisense that allows us to do the longer range forecasting, long range or the more complex analysis that's required by our type 2 systems. And so I'm going to guarantee that, because of the type of people we have on our webinar, we probably have some form of data warehouse in place today. And I think what everyone's also realized is that we need some form of modeling layer to accompany something like Snowflake, because it's having raw data inside of Snowflake isn't of great analytic value. So what I want everyone to take away from this is that I think we're getting to a point where our modeling purpose needs to serve two different types of audiences. One is it's going to have to serve the needs of the operational insights. So fast, reactive insights, reactive data needs that are going to go into a platform like Salesforce. And then we're also going to have to figure out a way to create models that allow us to do the longer range analysis of historical data. And that's where the business intelligence tool comes in. And so to us, the combination of a data warehouse plus a modeling layer is really, that's the foundation of how we build centralized data models today. So, and Dan hinted to this, he talked about some of the principles that they really evangelize at Dataform. And the value really is, I think it all boils down to be able to write our transformations in SQL, because it allows for code reuse. It allows to make sure that we can create definitions in SQL once and apply that everywhere where we need to in our business logic. So I want to now give you an example of how we take this concept and we start to apply it in some of the work we do for B2B SaaS companies. And what we've come to is that there's many ways to think of our data models, but the two fundamental objects that we want to build early on when we start working with the client is a concept of a user and a concept of an account. Now, depending on the type of company and the type of product that you work with, there's probably going to be, you can swap out the user for perhaps a person or a customer, and then the account can be swapped out for a team or a workspace. But by and large, the two models that we have to build is a concept of an individual and a concept of a group of individuals. So that's always going to have to be some of our early objective. And then there's a secondary objective, which is we also need a history table of how a user is evolving with our product or our customer experience over time. And then we need the equivalent table for the account. And so when we think about data modeling for some of our clients, we're not only trying to amass information across the different sales and marketing systems, but we have an end goal in mind. And we always start with this goal, which is how can we try to build out a model for a user and an account, and then historical models for both the user and account. And I'll show you how that's going to become the foundation for how we're going to route data into all our different platforms. So just as an example, what goes into this user table? So it's things like the lookups to all the different companion systems. So if you've got Salesforce in place, this user table would have a reference to their contact ID or their lead ID. It would bring in facts like the current state of the user. So are they active, are they disengaged, potentially even paying? It would have the current MRR on that account. It would have things like the total number of logins, login count per 7 days, and then depending on the type of product, you have roll-ups to the snapshot as of the current day. What's the actual product usage count? So as an example, for a product like Dataform, it might be how many queries am I performing within the Dataform product, or what's the total number of queries that this particular user has ever performed up until the current date. And then what we also want to build is a history version of that same table. So we can see either on a daily grain or on a weekly or monthly grain, how does that state of the user change over time? And you can probably imagine the analytic value of doing something like this. So if you ever wanted to perform something like causal analysis or trying to build any form of predictive model, that user history table becomes a foundational table for how we want to be able to predict user actions. And so our modeling objective really is very simple. We don't even bother going as far as looking at Kimball or some of the other traditional data modeling approach. Our objective is to try and build a consolidated user table and a consolidated user history table. And depending on the business needs, we start to add in fields to this table as necessary. What's also really interesting, or what's the technology choices that we have today make it really easy for us to try and build really wide tables, right? So the beauty of BigQuery, Snowflake, or Redshift is we're not constrained, or we're not worried about unnecessarily denormalizing our final tables. And so we can take advantage of how MPP databases work and ensure that, and try to design tables that are as wide as possible, knowing that we can, because they're stored on a columnar basis, we can always aggregate information up to the level that we need. So what that means is that those 4 fundamental tables that I just talked about become the foundations for how we send data, or we use data for analytics at any of our client companies. And that it specifically talks about things like, so the user table and the account table become the foundation for operational data into Salesforce, and then the history tables and the user and account history tables become foundations for how we do analytics work in something like Looker. And I wanted to show some examples of what that final data model would look like for one of our clients. And this is just one part of the DAG, but I'm demonstrating how we can bring in data from Zora or some subscriptions level and then map that into a specific user. So I want to give some examples of where we're headed. So I think it's an exciting time that we're working in this field, because there's a lot of interest in helping data models, or helping us develop data models much faster. And so Dan kind of hinted at this in his talk. So on one side, there's the idea of activity streams, which allow us to basically model the entire user and account history in a single table. And that's being taken up by companies such as Narrator. And we're really interested to see where that's headed. The other interesting thing that we're seeing today is, because a lot of our SQL code has become templated and it's something that we can reuse, we're seeing that data packages in the Dataform environment start to become really interesting, and they'll actually start to help accelerate a lot of our model development. So I'm actually going to end there, because I think I'd love to see some questions about some of the approaches that we talked about. But I hope that was helpful in helping folks on the call understand how we're thinking about data modeling for some of our B2B clients.
I think Josie is struggling with internet connection, so I'll step in and take over her role. Does anyone have any questions? Jim, you're not allowed to say no.
This is why you shouldn't take notes in the chat box. And then,
do you want to read out your question for Saadat? I think it's a good one.
Yeah, I mean, so this is kind of, I feel like I picked by going first. Okay, yeah, so you showed in fact, your slides were just really good. It was a great presentation. I took lots of screenshots. But you had this, the ELT-VA stack slide. And you kind of break down these different visualization tools which you can plug on top of your centralized data model. And what's interesting is, and potentially we went about this the wrong way, but we actually at our company have built a centralized data model. It's an activity stream model. But we sort of built it before finding the appropriate visualization tool, partly because I think we were really sold on the idea of the model and thought that, oh, it wouldn't be a problem to find a visualization tool that plugs into it. But we're using Metabase, and I don't think it's really designed for the kind of data model which we've gone.
Mm-hmm.
Is Jim breaking up for everyone else?
Yeah. I didn't catch the last 10 seconds in which
Hey.
Oh, you're back. Yeah.
I'm going to change the connection.
Do you mind if we're just repeating the last half of your question?
Okay, have you got me? Am I back?
Yes.
Yeah.
Okay, cool. Right, well, don't know. What I was going to say is, I wonder whether you think there's a particular layer in that stack that is best to start from, because the decisions you make at that layer affect the decisions you'll make at other layers. Basically, like where is the kind of critical decision point that affects your choice of other tools?
Yeah, I think it's a really good question. So I'll start with the BI layer. You're right in saying, like, I think, Metabase, it has a lot of merits. It has a lot of power. If you're early on, it's probably, what we find is it typically doesn't scale with a lot of our companies. So it's not even the types of charts that it allows for. I think it's just the way it's thinking about it's way it's thinking about collaboration for analysts. So it's thinking about like how queries you can perform. I think if everyone had budget, we would always recommend Looker, just because it's hard to argue against the merits of Looker's platform, because it really can do almost everything that you would think about from an end user perspective. But then we also shy away from making that choice, because we know how much work it is to not only implement a modeling layer in dbt or Dataform, but then also have to train the team on LookML. So yeah, I mean, this is an interesting thing. So we're finding that platforms like Mode are more suited to more of the fast-moving companies. So Mode would be an incremental improvement on top of Metabase, where it's got a lot of the collaboration tools built in, and it's also got a lot of interesting, it's got the ability to spin up a Jupyter notebook inside of the platform. So yeah, I mean, it's kind of that hybrid approach of, if Looker wasn't this giant endeavor for most companies to take on, and it also still allowed you to write SQL and jump into Python where necessary, that would be the platform of choice. But I will say is, what we find is, if you've designed your data model and you're pretty happy with the way it's working, replacing or doing a net new implementation of a BI tool, that's typically not that hard. So a lot of our clients, when if we're doing a replacement of Metabase, we're talking a few weeks to try and layer up putting something new on. That isn't always where we spend most of our time. But I think also, to echo your sentiment, if you've designed something as an activity stream, there really isn't a perfect BI tool for you right now. It doesn't really exist. But I'll also add to that, Jim, what you might want to look at is something like an indicative. So indicative.io, which is trying to take that same concept of I have event data, how can I visualize it really fast? I don't know if you've taken a look at that already, but I'm really intrigued. We've had some demos, and I think it's a fascinating product. So something to definitely consider.
I've heard it recommended a few times, and it's like definitely on my to look list. Okay, but it sounds like you think that the changing the BI tool, aside from changing to Looker, is generally quite easy. Whereas like the further down the stack you go, the decisions are much more critical. Cool, thank you.
We've got a question on the chat. Any thoughts on creating an alerting system? Would you recommend the data model approach or not? What are your experiences with respect to this? I think it'd be interesting to hear kind of like what type of alerting system you mean. But so yeah, jump out and mention if you feel comfortable. But I guess my kind of main thought on this would be, I think we're starting to see tools like Census and there's High Touch, and I think there's a Grouparoo now, even Looker kind of supports this. I think we're starting to see tools enter the data landscape that do make kind of alerting systems a bit more of a reality, something you might actually want, rely upon and be able to trust. I think the caveat is always that like data warehouses aren't really designed for like operational level reliance. And so I think alerting systems where it's around like, let me know how many new people signed up yesterday, just so I've got like a sense of what's going on with my business. I feel like alerting systems like that makes a lot of sense. Something that you would really never want to fail. I don't think I would quite feel confident as using the data model as a core kind of a core piece of infrastructure for that just yet. But maybe that'll change.
Yeah, I'd echo that sentiment, Benek. I think Dan's on the right track. I think we probably don't want to start building operational systems off of our data warehouse. But yeah, I think I just saw the new comment. If it's something like you're trying to build a sales report and you want to highlight that there are 15 deals that are, it's 5 days from the end of the month, but there are 15 deals that are still in a particular state, which indicates they're not going to close. That's the perfect type of thing you could build off of a data model. One of the things that we've been working on recently is the idea of customer health, and we're playing with the concept of trying to identify customers that have declining health scores, and using the data model to alert staff customer success staff when that is about to happen. And it's a combination of a BI tool plus a SQL query, and then an alert into Slack. But that's, yeah, I think there are certain use cases where you could use your data warehouse and the corresponding centralized data model to power some insights, but definitely wouldn't want to power the entire operational insight for a company off of that. I will say one more thing to that, and it was interesting because I was in the Fivetran webinar talking about their product roadmap, and one of the neat things that they mentioned is they're trying to get their latency for the replication speeds down to minutes. And so, if right now, if let's say the minimum latency that you can have on Salesforce or HubSpot or any one of those connectors is in the order of 15 to 20 minutes, their target is to try and get that down to minutes or seconds. So at some point in time, Venica, you will probably be able to even build real-time reporting systems off of our data warehouse. But I think we're a few years removed from that yet.
Cool. We have 2 minutes. Does anyone have like an extremely quick, pithy question for Saadat, just to round us off? Favorite SQL query, most, I don't know, what you're having for dinner. Jordan's question: one Y table or a few tables at different granularities?
Yeah, Jordan, I'm a fan of the one Y table. It's funny, once you get to the point where you've got the model built, I find we're spending most of our time querying that one table anyway. So I think it's a generalization, but if we can make that happen, it'll be very powerful.
Cool. Let's wrap up there. I think, yeah, that was a great talk. So thanks very much. I think it was, yeah, nice to kind of take a bit of a step back and think about the kind of more kind of top level view of how data modeling can really change a business. And I think, yeah, there's lots of, if I was a B2B SaaS company looking for a data consultancy, I'd be coming to Modern. So yeah, thanks for joining. Thanks for all the questions, everyone. And yeah, we have another webinar in a week's time talking about data quality. So yeah, hopefully see some of you. See ya.
Thank you.